The power of heat transfer. We know from the specific heat capacity equation that energy in joules is equal to mass in kilograms times specific heat capacity in joules per kilogram per Kelvin times the temperature change in Kelvin or in degrees Celsius. We can write that as Q equals mc delta theta. Also, we know that power in watts is equal to energy transferred in joules divided by the time taken in seconds. Many heat transfer systems use a pumped fluid undergoing a constant temperature change. In this case, the power will be the rate of flow of mass multiplied by the specific heat capacity multiplied by the temperature change. So we can write P is equal to change in mass over time taken times C times the change in temperature. For example, a domestic radiator takes in hot water, transfers some of the energy to the room before the water leaves at this end at a lower temperature. In this case, the power output of the radiator will be given by this expression. So if 10 kilograms of water with a specific heat capacity of 4,200 joules per kilogram per Kelvin at a temperature of 70 degrees Celsius enters the radiator every minute and leaves at 65 degrees Celsius, the power output will be given by this expression. Putting in the numbers, we have 10 kilograms over 60 seconds multiplied by the specific heat capacity of water multiplied by the temperature change of 5 degrees Celsius or 5 Kelvin gives a power output of 3,500 watts. In a car engine, water is pumped around the cylinders to remove the excess heat. When the engine reaches its operating temperature, this valve will open and the hot water then passes through this radiator like this, transferring heat to the air passing through. If necessary, a fan can be used to draw even more cool air through the radiator, removing the excess heat. In a refrigerator, a fluid is allowed to expand, becoming a cold gas, before entering the cabinet. It then absorbs heat energy from inside the refrigerator. It is then compressed back into a liquid. It then rises in temperature, so it can now transfer the heat energy gained to the surroundings.